Okay, Miss Howard's Chemistry Unit 12, Acids and Bases. Continued. This should be I'm thinking more on part 5 here. Alright, and we're going to focus on distinguishing, down at the bottom, Teeks distinguishing between degrees of dissociation for strong and weak acids and bases. Alright, we talked about the fact that strong acids and strong bases conduct electricity well, weak acids and bases not so much. So acids and bases are classified by the degree to which they ionize. Okay, underline that word ionize, circle it or something, because ionize means they separate into ions. You have covalent compounds and you have ionic compounds. Covalent compounds are between two nonmetals and they share electrons. Ionic compounds are between a nonmetal and a metal and they transfer electrons, right? Ionic compounds have ions. Well, acids and bases, well, specifically acids especially are hydrogen plus usually some non-metal over there. So HCl, chlorine is a non-metal. They don't form ions. You know, they're not naturally ions. So when you take that HCl, that hydrochloric acid, and dip it into water, it actually separates. It creates ions where none existed before. So they give it the name ionize. All right? So they ionize. Strong acids and bases completely ionize. They completely dissociate or separate into water, in water. So you have the H and the Cl, and they pop apart. So you have the H plus ion, and you have the Cl minus ion. Strong acids and bases are strong electrolytes. Weak acids and bases are weak electrolytes. So when they say strong and weak, they're not talking about the fact that, hey, if you stick your finger in there, it's going to burn really bad. They're talking about if you stick something in there that's maybe attached to a light, is it going to light like our conductivity testers? Is it going to light up both lights or only one light? Okay. Weak acids, capital letter B, they only ionize just a little bit in aqueous solutions. So strength and concentration are different. Strength means if it's strong, it ionizes completely. It's a great electrolyte. And weak means it doesn't ionize completely. It's a very crappy electrolyte. Concentration means how much acid did you put in that water? How much base did you put in that water? So strength and concentration are different things. Concentrated and dilute tell us how much of the acid or the base is dissolved in the water. Okay, tell us how much. The words strong and weak for an acid or base refer to the extent of ionization. How much do they separate into ions in the water? So, can you have a concentrated weak acid? So let's see, a weak acid example of a weak acid would be acetic acid, vinegar. Can I have something that has a lot of vinegar and a little bit of water? Sure. I can have a concentrated weak acid. Yep. That's what they're talking about. It won't be a great conductor of electricity, but it'll be really concentrated. Right, so if you have a weak acid and a base, they don't ionize completely, so we're just going over this again. They're a weak electrolyte. And you see my little test tube apparatus, and the light's a little dim over there. So here's an example. Hydrogen fluoride, that's an acid. That's a weak acid. It pretty much stays together. Most all of it stays together. Just a little bit of it separates into ions. You have to have ions in order for electricity to run through there. And listed on the left-hand side, we've got some weak acids. And if you look at them, they're written a little differently than what you see there. Like the second one, in most cases you see it as HC2, H3O2. They're just different ways of writing some of the, especially when you talk about the organic acids that have carbon, so you'll see them in different ways. So there are weak acids over on the left, and there's one major weak base in H3 over on the right-hand side. Alright, so this next picture, it says a very weak acid. So H, all acids begin with H. And then the A, usually it stands for the anion, the negative ion that's associated with it. Positive ions go first, negative ions go second. So the H is the plus, so the other anion, the other ion that's with it is the negative one. So you put these weak acids in water, and most of it, the H and the A, the two parts of the acid stay together, and just a little bit of it splits up into the hydronium ion and that negative ion that's with it. Not a whole lot. As a matter of fact, there's a whole section in AP Chemistry where we talk about, well, how much does it separate out? You don't want to talk about that right now. Okay, strong acid and bases, they are 100% ionized in water. They're strong electrolytes. You know, it lights up the little light bulb over there very nicely, very nicely. So when you have the H and the Cl, they completely separate. All of the H's separate from all of the chlorines. examples of strong acids are on the left-hand side: HCl, HNO3, H2SO4, HBr, Hi, HClO4. And on the right-hand side, you have some strong bases: sodium hydroxide, potassium hydroxide, calcium hydroxide, barium hydroxide. All right, so when you have a strong acid, you put this acid in there, and you put it in water, and there is no acid two ions bonded together anymore. They're separated into the ions. So man, that electricity just zips right through there easily.